name is Byron Chen. I'm here to share with you some of the results that we have done in Alcatel-Lucent. Excuse me. Alcatel-Lucent is one of the major providers of infrastructure to Verizon and AT&T. So, and inside the company, we have LTE geolocation subteam, and we look at the location-related issues and try to find a resolution. I present here some very classical location enabling technology based on TDOA. So it's a dynamic TDOA and uplink TDOA. And why we're still looking at it, the way that we look at it is eGPS is of course the main course for a location. Unfortunately, it doesn't work all the time. And then we have all those novel technologies such as our pattern matching, and also Wi-Fi, like this bit, and all those wonderful technologies that seemingly can take over TDOA message to say, please, you can go. But the way that we see it is a TDOA-based message is low cost and it's reliable. And there are some work done in the 3GPP standard body as well as inside the company, try to make it better. So this is what I'm going to present. We look at the background and downlink and uplink TDOA deployed in the 2G very quickly. And then we'll look at we expecting better performance of downlink TDOA in LTE. So okay, for sure that we can make an EDFCC mandate with AGPS. Then we look at why we still look at UTDOA since we have the downlink OTDOA, which works fine, and we have other wonderful technologies. So why are we still looking at it? Now, one other thing that we said is that because UTDOA can locate every single active mode, and beyond that, we can combine the location of every single mobile with the presence. By presence, I'm not meaning that it is just active or I mean that what applications that each mobile get involved. Of course, there's a privacy issue, and then we can have a discussion on that. So lastly, I have updated if we have time some of the locations that applications we can take a look at. Every single of those applications require locating every single mode that are active. Okay. You can get to the extent that they're tracking every single mode, but there's privacy. So here's the background, AFLT and CDMA, which is deployed by Verizon, and then uplink TDOA deployed by AT&T. This is an overlay system provided by True Position, which involves high cost, and I don't think AT&T likes it. So moving into LTE, they probably want to do away with it. The downlink TDOA, when we get into LTE, together with eGPS and enhanced LED, has been specified by 3GPP in release 9, so which is done. Okay. And the UTDOA stays as a study item in release 10. It's not likely to be standardized before the end of 2011. So if you want to use UTDOA for meeting the FCC mandate, probably you cannot catch up to the really deployment schedule. This is one of the major things that we have done in the 3GPP and internally in ALU is hearability improvement by PRS. PRS stands for Position Reference Signal. You look at this position reference signal, they show up in a subframe a lot of times. And they're going to be transmitted in a number of subframes and then periodically. So what it helps you is the mobile can improve its hearability, means detect more base stations near around, such that we can do triangulation, not just triangulation. Right? We detect 4 or 5 nearby base stations, then detectors need to rapidly improve. And we're going to take a look at the expected accuracy. So this is just it's just a graphic example that in the CDMA mostly mobile can only detect signals from 2 base stations, sometimes 3, sometimes 1. But in average, it's about 2. But moving into LTE, we expect mobile can detect 5 base station signals around. Why is that? Because if you look at the PRS signal, then we're going to shift the PRS see the frequency shift. The vertical is frequency, and the horizontal is the time. Okay? So you're going to see that we can shift the frequency from subcarrier to subcarrier among different neighboring base stations, such that when a base station nearby transmitting position reference signal, there is little interference because all other base stations is going to be automatically muted for those points. Of course, there's an impact on capacity, but if you control the number of subframes and you control the periodicity, the impact to capacity will be controlled at 1 to 2%. Since this is periodically transmit everywhere, so you can use it for location-based service because every single mode can do it, right? Check it, determine the position. One other thing that we've done internally inside Alcatel-Lucent is we look at the tight ENOV synchronization to GPS time. Back in the CDMA time, we know that every single base station synchronized to GPS. But the standards mandate is 10 microseconds. 1 microsecond is 300 meters. 10 microseconds is 3,000 meters, which is totally not good for TDOA. Nevertheless, the AFLT, which has been standardized in ISA1, still works to some degree, which helps such as rise intermediate season mandate because inside Lucent that we build base station with a synchronization requirement of 1 microsecond. And this is like if you do a Gaussian model, 1 microsecond is like a standard deviation, right? So most of the time you still see base stations synchronized. Nevertheless, if you cross vendors, then you got to screw up because vendors deliver base station in different requirement of synchronization than AFLT performance is fluctuating. Okay, that's for 2G. But going into 3G, if you look at the architecture of base station, we're going to calibrate the transmitting path delay from GPS antenna all the way to radio antenna. So all those delays are different components which can come up to several microseconds and even beyond 10 microseconds will be compensated such that the modem will adjust the frame start. And when the frame being transmitted at the antenna point, they are synchronized across different units. Now, how tight we can do that? The target that we put is 100 nanoseconds. And if we do a math, 100 nanoseconds is 1/10 of a microsecond. 1 microsecond is 300 meters error. Right? So 100 nanoseconds, 30 meters error. This is the expected downlink OTDOA accuracy through simulations, and we assume that the PRS, position and reference signal, being implemented. And you can see those curves, which represent 3 ENOV, means the mobile can hear 3 ENOV signals, 3 base stations. ENOV stands for Evolved Node B, which is a name for BTS in LP. So whenever you see me talk about ENOV, that's a base station. This is for 3 ENOVs and 4 ENOVs and 5 ENOVs. Mean that mobile can hear 3 ENOV signal, 4 ENOV, and 5. The accuracy gets better. This assumes hearability. So if you look at this, say here is a 50 meter, horizontal axis means error in meters. You will see if mobile can detect a 4 nearby base station signal, the accuracy is around 60%. 50 meters. And 150 meters is about 92%. Now, by looking at the accuracy of the TDOA, that you know that itself cannot meet the FCC mandate. However, because it's a supplementary method, we hope to build a TDOA method, which is a solid, low-cost piece supplement to AGPS. But we would never claim that TDOA can solve the rest of the problem besides GPS, because there are some deep indoors that you really cannot handle. And also for some of the rural areas, if you are inside the house and all the base stations are far away, and you can't even hear 3 base station signals, right? So I would say that what TDOA method can do is suppress the gray area left out by AGPS, such that we leave the hardest core to Wi-Fi and pattern matching based method and whatever method we can come up with. All right, so much for TDOA based method. This is a summarization of the 3GPP test. AGPS plus TDOA plus NSL, the 3 methods being standardized in an LTE, and there are more methods going to be standardized. So we are confident that this package of a method is going to meet the FCC mandate, even though we cannot solve all the problems, but statistically we can meet the FCC mandate. Potential issues here that we see is recently the standards passed decision that RSPD, which stands for Reference Signal Time Difference. This is the key value that the mobile has to measure in order to allow TDOA. So there's a decision that the error allowed to be plus or minus 5 TS. 1 TS 32 nanoseconds. So combined 5 TS is 160 nanoseconds translated into 48 meters. You can imagine that this error is like a Gaussian sigma, right? Standard deviation left and right. Nevertheless, it gives you some warning signal that mobile vendors may come up with handsets with different performance. So you're going to see variations in TDOA performance from different vendors. So early trials can reveal those possible variations and try to mitigate. Now I'm moving to why we still look at the UTDOA. The number one reason is, I said before, we're looking at the location plus presence. And presence is not just what mobile is active or idle. We also look at what possibly, what application mobile is getting involved. And I'll show you an example. Second reason is that there are strategic alternatives to meet the FCC mandate, because there are service providers who do not want to put a GPS into every single handset, because there are certain, a large percentage of users probably wants low-end mobiles, and they don't want a GPS. So in this case, then the UTDOA provides alternative that you use the UTDOA as the main course. But at the same time, you can leverage those high-end mobiles which has a GPS and use UE-based AGPS to supplement UTDOA. And in that case, you can still meet the FCC mandate, because this is 100 meters, 67% high, 300 meters, 95%. So you get a relaxed mandate in terms of accuracy. So those are the two motivations that internally we look at the solution. We look at the existing UTDOA solution deployed by one of the major service providers in North America. And the cost is too high because you have a standalone value and you have a maintenance of the network, which is the yearly cost very high. So moving into LTE, this is almost impossible, not just because of cost, because the user data comes in huge quantity. And also because the LTE network, by operation itself, is based on the schedule. You have user data scheduled at different sub-carriers, at different sub-claims, and outsiders have no idea when to catch which user's data. And only base stations, because base station does the schedule. So this is almost an obstacle that you cannot cross if you're using outside standalone LTE. Now this is a new generation of UTDOA that we look at. Because of North America FCC mandate, GPS is being put almost every single base station. So the LMU, why LMU cannot be sucked into each of the base station, and we supplemented it with additional functionality. So we make an integrated LMU, which is a low-cost LMU. So this is the idea. We look at this same architecture again. Say, what do you need to do here? You already synchronized to GPS. You already calibrate the transmitting path for downlink OTDOA, and then you need to do another work. You need to calibrate the receiving path. Because when you do UTDOA, base station receives the signal. Base stations detect the signal of arrival. But the arrival of the signal detected at the baseband, which is at the mode. So you need to calibrate those receiving paths. Nonetheless, in the previous picture that I showed you, there are three methods: AGPS, downlink OTDOA, enhanced cell ID, are being standardized by 3GPP. To support enhanced cell ID, we have to provide advanced timing advance. And to make timing advance represent the over-the-air delay, we have to calibrate transmitting and receiving paths and remove them from the timing advance. So this work has also been done. Now what's been left for supporting UTDOA at the end of it is to detect the signal arrival accurately and to process it. And then process the signal to the upper level. And that's all you need to do. And we think this is a low-cost approach. So here is some simulations about the UTDOA. And we're using the sounding reference signal, SRS. This is an uplink signal scheduled by base station. And mobile transmit from time to time, try to get a good knowledge about the channel property. So base station knows exactly mobile should transmit the signal and knows exactly what signal is transmitted. This SRS has a big problem because there are interferences from neighboring base stations. The other mobiles in neighboring base station are transmitting SRS, try to detect the property of their channels. So if without this SRS interference cancellation, you see performance or accuracy like this. Horizontal, again, this area in meters, and vertical is the probability. This is a comparison that after you're done with SRS interference cancellation, there's some proprietary algorithms that you do that. And we'll hope that this algorithm only affects at most software or firmware, and nothing impact on hardware. This is an ideal case. All the SRS interference being canceled off because the simulation, you know exactly what's happening. Going into the field, you may not get this superior accuracy. And to mention more, that we put in 10 dB and 20 dB penetration loss, because you imagine that if you're in an indoor, we'll talk about light indoors, that you're going to see 10 dB, 20 dB loss. So the parameter we use is a base station sensitivity. We think that we can afford to put in better hardware at a base station. Sensitivity is minus 93.5 dBm, and UE transmitting SRS signal at 23 dBm, which is the maximum power. And you don't have the luxury to force mobile transmitting at the maximum power all the time. So battery consumption is this. Now there are still potential issues. UTDOA is likely to be a standardized location technology before the end of 2011. Therefore, it cannot be used for E911 if you deploy LP earlier, such as Verizon, maybe by AT&T as well. The other potential is that the burden is on Innovina, right? It's not mobile detect downlink TDOA signal. It's the base station detect uplink TDOA signal. So it has to handle SRS detection, hearability enhancement through SRS interference cancellation. And then the algorithm of those is still under study, and because this is never been an easy job. And there is an impact on software and hopefully UTDOA can still be a candidate for location technology upgrade if you deploy the downlink OTDOA. And I found out that the performance varies too much. You say, I want to upgrade to UTDOA, and let the base station share some burden of locating every single mode. You can still do it. It's a low cost upgrade. So early planning of UTDOA to us is important because we don't want to impact on, we later on we say we swap out your base station to deploy UTDOA. It's never going to work. So there are some early planning and studies to go. I'm not representing product manager say it's going to be available because we have this 5D geolocation team which has product manager. Has a lot of researchers, we have standards reps, we have a system engineer, which is, I happen to be the one coordinating all the effort. Those are the references, some of them are already low. I'm sorry, there's too much of it. It's okay. Yeah. We kind of give just one slide. 3 classes of location-based service. Class 1, E911. It's mainly free, so no problem. Not for problem. Class 2, user plane. We see limited profit from us. We just selling features and supporting some location technologies. Those are for individual users. In the LTE, we put our emphasis onto location-based service for enterprise customers. That means that we have to locate every single mode and all the time. Okay, there's a privacy conflict, but how we manage it is just collecting statistics. Now this is the last slide, and take a view, bring you into and see what we can know if a mobile is involved in a certain location. You see this is 3GPP standards. By matching the QCI, what does QCI mean is QoS quality of service class identifier. So you see all those application mobile involved implied by QCI. You not only know whether the mobile is idle or active, and you know roughly what application mobile is involved. That's what we mean. Combine location and presence. Support enterprise users. Efficient advertising is one of them. Traffic jam prediction, another one. There are many applications you can think of. So this is my presentation. I think that I've used too much. Question?
Yeah, you mentioned the use of this technology, the UTDOA technology in devices without GPS for low-end devices. But I think virtually all North American carriers have signed up to the county-by-county requirements. And when you get to rural scenarios, one of the most typical cases is you have a single serving sector, in which case this technology doesn't work. And if that's true for the entire county, you won't be able to meet the mandate in that county. So do you still stand by this as a technology for 911?
There will be problems, as always, and even for downlink OTDOA plus the GPS. What we think is that the hybrid approach will be used by all major carriers, combining the Wi-Fi, the indoor, and with this UTDOA technology. And as I said, UTDOA is unlikely to be used for E911 because of the problem schedule. But it could be if you use certain approach. For me, when I look at the deployment schedule of service providers in North America, I don't see maybe.
Okay. Beyond North America, there are operators who use uplink time difference to track mobiles for security purposes. You can't use AGPS or downlink because it has the active involvement of the mobile, and they want to track the mobile without the knowledge.
Exactly.
And hence LID is not really a viable technology because of the accuracy. So what is AOU's position on that?
This is involving a particular regulatory application, right? So privacy is not a concern. In this case, if you look at this, when you deploy UTDOA, here is the mobility management entity. It knows every single mobile's IPs. So if you pull the location and presence data from the V2MME, you can actually match the temporary ID, user ID inside the InnoV has no knowledge of the IMSI, but MME does. So you can match the two. You can do the tracking. It's not down to the GPS accuracy, but GPS needs user intervention. UTDOA doesn't.
Question? Is there a question? Question, did you have a question?
No, I don't have a question.
Thank you.
Byron, thanks a lot.
Thank you.